Hurley. I'm Developer Programs Engineer at Google. And this is Mark Cohen, also Developer Programs Engineer at Google.
Hello.
And we both work on Google Compute Engine. So in this session, we're going to show you how to get started using Google Compute Engine. So first, what is Google Compute Engine? This Compute Engine just launched at infrastructure. What is it all about? Basically, this is what Google's infrastructure already handles. It indexes billions of data that's written to and from your VMs. All the data is encrypted, so it's very secure. Again, is one of the engineers' number one priorities. Another guiding principle was that the system is open and flexible. And basically, you're given a VM, you have root access to this VM, so you can install pretty much whatever you want on this VM, which allows very flexible environment for you to develop applications on. They were also concerned, the engineers were also concerned about consistency. So they want to make sure that any application that you got running on Compute Engine would be consistent and run consistently. So it works once and it always works. The system, Compute Engine, is also proven. So a lot of Google's production services are already running on Compute Engine. And finally,
sorry, I just wanted to stop you for a second. I'm getting some reports that people aren't getting audio when we cut to the slides. We're okay? Okay, it's fixed. Sorry about the interruption.
Okay. Sorry, 1 second. And should I go back and go over any of the slides, or are we good?
Not sure how much audio we lost. Maybe carry on from where you left off, perhaps.
Okay. And finally, the engineers and the team in general is just very interested in enabling an ecosystem on Compute Engine. So we have an API that you can use and incorporate into your own application. So we're very interested in partnering with you to help you include Compute Engine in your projects and applications. So what I wanted to do was just jump into a little demo right now, and show off the Compute Engine UI. And the UI is available in the Google API console. So I'm going to switch to that view right now. So if you just go to code.google.com/apis/console, this is Google's API console, and you have control over all of Google's APIs via this console. And you have the opportunity to create projects here. I have a project called Google Compute Engine that I'm going to be working in. And you can see some information about my project here. And you can see I have Google Compute Engine enabled on my project. So, and it looks like I don't have access to this project. Shoot. I guess I can't have more than one account in. Let me see. Sorry, I'm going to sign out
and sign back in.
Give me 1 second, sign out and sign back in. Sorry about the delay. All right, here we go. So again, this is Google's API console, and I was going to click on Compute Engine here. And you see I have a Compute Engine project called Compute Engine Demo. And you can see some information about my Compute Engine project. I have 100 instances available, 100 CPUs, and some other information. I can see a list of all the instances I have up and running. So I already have an instance called Demo 1 up and running. I can create new disks here if I wanted to do that. I'm going to skip that for now. And you can see information about networks that I have in my project and zones and operations. Let's just go back to instances. And I want to create a new instance now and just show you how easy it is to get an instance up and running. So I click on Create Instance button. And you can see there's a lot of options here in this UI. So I can give the instance a name. I'll just call this Demo 2. I can apply a description. I can select which zone I want the instance to get up and running in. I'll keep it the default for now. I can select the machine types, which allows me to select the number of virtual CPUs for my instance. I'll keep it as the default. If I had images, a custom image, I could apply it, or I could select from one of the many default images to apply. And there are several other options, but this looks good for now. So I will create a new instance. And you can see this instance is provisioning right now. And it's going to go through provisioning and staging and get up and running. And it's staging right now, so it's pretty quick. Let's just go and look at this one that's already up and running. And you can see some information about this instance that I've already started. So you can see information about the zone, machine type, the disks that I have for this image. And what's pretty interesting down here is this SSH command. And I could just copy this and paste it directly in my terminal window, and this will allow me to SSH directly into this machine. So that's pretty handy. All right, so let's go back to the slides. So now I just want to talk about the overview of Compute Engine and talk about some various components of Compute Engine. So first we have the concept of a project, and I briefly showed you that in the API console. That's an API console project, and the project owns all these resources. Then we have the compute components of Compute Engine, and that's basically your VMs that are doing all the work for you. Next we have the network and storage and API and tools. And I'm going to talk about each of those individually. So the project, again, it's based on the API console projects. You create project in the API console. And this project is a container for all your Compute Engine resources. So the project owns the VMs, owns storage, networks, etc. And you can invite specific team members to join the project and work on that project with you. And also billing is enabled for that project. The compute powers the VMs, and so these VMs are Linux virtual machines. You have root access to these VMs, which means you can basically install whatever you want on it, which is really cool. You can choose from some of the stock images. We have Ubuntu and CentOS images, or you can create your own custom images to apply to the VMs. There's a modern processor, Intel Sandy Bridge, and you can select the number of CPUs and RAM for your VMs. Next is the network. So all the VMs live within their own private network, and it's isolated per project. You're given a private IPv4 space. And one thing that I find pretty cool is there's an internal facing DNS. So the names that you assign to these VMs are also the DNS names for the VMs. So it's easy to communicate with that within your private network of VMs. So you might also be interested in allowing communication with the external world. So allowing computers to connect to your VMs or vice versa. So each of the VMs has an external IP assigned using one-to-one NAT. And you can use firewalls to allow TCP connections to your VMs or allow other protocols. Now storage, so if you decide to do so, you can have persistent disk for your VMs, and persistent disks are provisioned via the API, and they are located in the same zone as that instance, and since the team is very concerned about security, they are encrypted. You can use ephemeral disk instead if you want to, or in addition to your persistent disk. Ephemeral disk, it lives and dies with the instance. So as soon as that instance shuts down, it's also gone as well. And that's because it lives on the same physical machine as that instance. And again, this is also encrypted at rest. And finally, you can also use cloud storage for your storage needs. And this is an Internet Object Store. It's similar to EC2. There's an API where you can access the objects in your cloud storage buckets. What's really cool is there's frictionless access to this to cloud storage if you use service counts. So basically, when you start up a VM, you can say, okay, I want this VM to be able to access cloud storage as well, and you can immediately use gcutil on this VM without having to worry about OAuth at all. All right, so finally, we have a few tools that you can use to access Compute Engine. There's a command line library called gcutil, which makes it really easy to add instances, list instances, create networks, etc. I showed you the Compute Engine UI, and that's available in the API console. And then finally, there's code, and that's you. So we're very interested in forming partners and creating an ecosystem around Compute Engine. And we have an API that allows you to use Compute Engine in your applications. All right, so gcutil, just go through gcutil real quickly. That's a command line utility library. And here are a few examples of the commands that you can run. So you can start up a new instance using the gcutil add instance, and you provide a name for that instance. You can list all the running instances using list instances. You can even apply filters to listing out the instances. So if you want to find all the instances that are running, you can filter for status equals running. If you want to add a new network, you can use add network and provide a name for that network. Here we're calling it prod. And finally, you can add set up a firewall to allow your instances to accept incoming HTTP connections. All right, so I'm going to have a API demo, but due to the account issue, I'm wondering if I should cancel that. Can we switch away for a second while I set it up? Yeah. Give me just 1 second to set this up.
Just to amplify the last point about the network configuration, where just give me a yell when you're ready. Are you ready now?
Sure.
Okay.
Maybe that works.
I'll finish the thought. Basically,
Yes,
Catherine showed a command line that was configuring access to port 80 for the network. And in case anyone was wondering, you don't have to do that. By default, your network will come up with the ability to accept SSH connections. So I think that's port 22 SSH. Not exactly sure the port number, but it'll accept SSH connections from virtually anywhere, and it will accept allow all traffic between instances within a given virtual network or cluster. Other than that, you would want to use that command Catherine showed you to augment the firewalls to allow additional access.
And yes, it is 22.
Cool.
Cool. All right, should we go to the demo now?
Sure.
Okay, just real quick, I'll go through this demo. So I set up this little App Engine app that starts up instances. And I'll get those up and running right now. And basically, this App Engine app uses an App Engine task queue. And so the App Engine app sends these tasks to the task queue, and each task is going to start up a VM using the Compute Engine API. And you can see these are all the VMs that I've asked Compute Engine to get started running. And as they turn from red to yellow to green, that indicates the various status of the instances. So red is when they're provisioning, orange is when they are staging, and green is when they're actually running. And so when they're up and running, they get placed in this little waiting period. So they're basically waiting for a file to get uploaded to cloud storage. So when I click at this fractal time button, there's going to be a file that's uploaded to cloud storage, and all the VMs are going to be like, okay, that file's there. And so they'll continue with their work, and they're all going to generate one tile for this fractal image. And as you can see, they're filling in all the tiles right now. So that's basic API demo. You can do so much more with the API, but this gives you an idea of the kind of thing that you can get up and running really quickly. This took me less than a week to get up and running.
And we're going to make this available soon.
Yes, so we're going to share the code with you to help you learn how to use the API. And let me just go back real quick. So a little bit about the API. It's a REST API. And here's just a basic example of an HTTP request that you make to start up a VM. So you send a post request to this URL, and then you send, oh, that's very yellow. You send a JSON object representing the instance that you want up and running. So I just want to provide a couple helpful links to you. So you can sign up for Compute Engine here. It has a few instructions of what to do. And I also want to provide a link to the docs, so you can read the docs at this URL. And let's see. All right, thank you. That's all I have. Here's some information about me if you want to get in touch with me. Leave that up for just maybe a couple seconds. And I think at this point we're going to go to the moderator that we had and answer the questions that people have posted. The moderator was available in the Google Developer Live session, and I think we can just read off those questions and answer them. So if you want to help me out.
Sure.
Mark?
Yes, we have the top question right now is, do you have API client libraries, and for what language?
Yes, we have.
We do have languages.
Yes. Let's see. I could even try to find.
So while you're navigating, I'll mention that Google has kind of a comprehensive set of libraries for multiple languages, covering most of the popular programming languages that are used now. So Java, JavaScript, Ruby, Python, PHP. Oh, well, there's the list.
Yes.
And so those are all available for use now with Google Compute Engine's API.
Yep. Go, GWT, Java. So we've got several. And I use the Python client library to build that sample application on App Engine.
Let's see. Is there a free tier that we could use to test out applications? Actually, before I answer that, one more thing I wanted to add is did you mention the GCE Lib? So
Yes.
There's another library that you guys should know about in addition to the standard Google client libraries. Catherine's bringing it up on a page right now. So this is called GCE Lib, and this is a kind of a reference library for what we think is a really great abstraction layer in Python. So it's specific to Python, but we think it's a really nice programming paradigm, and we'd like to recommend people give it a try. Really natural, object-oriented structure for accessing the Compute Engine capabilities. So that's another option for people who are interested in Python programming. Is there a free tier that we could use to test out applications?
That's a good question, and I'm not sure the
Yeah,
answer to that one.
I think the answer is that right now, yes, there is a free tier. We haven't officially set the rules as far as the free quota, when that's going to be introduced. So right now, all access is free, but we're definitely moving to a model where we're going to be charging. And the pricing for the charging for our service is on that same page. That's in the second link on Catherine's page. Or actually, yeah.
Okay.
So if you go to developers.google.com,
Pricing.
yeah. So right now we're in the limited preview period, and during that phase, the pricing is free, but we'll have further details on the actual charging mechanism when we get to the next stage of the service. Time frame to get access to test Google Compute Engine instance. So this is I don't know if you wanted to.
That's a good question again. Lots of good questions. We just encourage you to sign up here at this form, and we will get to your request as soon as possible. So right now we're spending a lot of time just making sure that the service is running well. You know, we want to make sure Compute Engine is the best that it can be. So we're in limited preview right now, as was mentioned. And so we're letting people in little by little and making sure that Compute Engine is the best that it can be.
Right.
And it is production ready. We should also mention that.
Right. We do have production Google services running on this this product, and we just want to make sure it's going to be the best possible experience for all users. So we're scaling it carefully. Next question is, would it be feasible to boot the instances with a persistent disk mounted at root? My understanding is the persistent disks have to be mounted yourself, formatted and mounted yourself. And so there might be a sort of a chicken and egg problem there, but we have one of our engineering leads on the Hangout. I'm not sure if we're able to switch to include audio from a Hangout attendee. Is that possible?
Can you hear me?
There's Joe, and I'm hearing you, actually.
You
might have to speak up.
Okay. I hope everybody else can hear me. The question about booting from persistent disk, that's something that we're working on, and that we're looking at very carefully. Obviously, that provides a much more persistent feel to the virtual machine than booting off of ephemeral disk. We want to make sure that we get all the right features set up there so that we can provide a great experience there. But that's definitely the direction that we're heading. And then user will be able to choose whether they want to boot from persistent disk or from ephemeral disk.
Thanks. Next question is, this changed right in front of my eyes. Let's go down the list here. Any plans to introduce an auction-based pricing model like EC2 spot instances? We'll consider that input. We don't currently have specific plans to do that, but we really like this kind of input, so we'll take that into consideration. How secure is this about hackers and other security issues? Really good question. There's a lot of dimensions to security, and so I just want to mention a couple of things that I think make this product really well situated to keep your data secure. A lot of really deep engineering work has gone into isolating the instances and the networks so that when you actually visit your instance or interact with your instance, we've taken great pains to make sure that other people's instances can't come along and see your data or your instances, and likewise you can't get to other people's data. And there's a lot of work to firewall these instances from Google as well. It's up to you whether you're going to use HTTPS or HTTP. We recommend HTTPS for encrypting a lot of for all your data that's in transit as a general rule. And as Catherine mentioned, the data that's stored at rest on the ephemeral disks and the persistent disks is all encrypted. So the combination of all those things, we believe, yields a very secure platform for application developers. I don't know, Joe, if you wanted to add to that at all.
Yeah, I mean, I'd like to, just a couple of things. I think that's a great summary. The first thing is that at the API level, we're leveraging a bunch of common technology that Google's built around servicing APIs, and all communication to our API goes over HTTPS. And we do things in our clients like make sure we check the certificates that we get back, which is actually a common problem in API clients. The next thing is that our default images, and we offer both CentOS and Ubuntu-based images, we've done a little bit of work to harden these down a little bit to provide some good defaults. Now, we can't go all the way to sort of guarantee security for what's running inside the virtual machine. I mean, with great power comes great responsibility, and having root on the machine means that there's a certain amount of ability to shoot yourself in the foot. But we've tried to do some common sense things, like using SSH keys instead of passwords is a great way to do this. We don't allow SSH to root by default. We actually disallow password authentication for SSH by default. We've turned on automatic updates for the various distributions to make sure that you get the latest security packages installed. Now, you can go in and modify all this to turn any of these capabilities off if you really want to, but we wanted to make things be as secure as we could by default for things that make sense.
Makes sense.
Great
Thanks,
answer.
Joe. How do I configure my instance on startup? There's a couple of answers to that.
So there are startup scripts, and you can specify a startup script, and this gets run when your instance is started up. And another option is to create custom image. So you can also select a custom image to apply to an instance while it's starting.
And maybe we can just really quickly summarize the process of creating the custom images. So you'll basically you'll create an instance using one of the standard default images, and then you'll customize that to your needs. So you might install, a web server or some sort of package or your own custom application software that you're interested in using. And once you have the configuration exactly the way you want it, we have a script that kind of makes the process pretty easy. It writes a tarball, compressed tarball file to the local disk, and then you store that in cloud storage. Then there's an API call you can make, or it's visible through gcutil as well, that you can run to assign a mnemonic name to the image, and also to tell it which cloud storage object to use for that image. And then from that point forward, you can create instances with that tag as the requested image. And I think those images will also show up on the console API, as far as I know.
Yes. So you can select that from the drop-down menu when you're creating your instance.
Yeah, so if you prefer using the web UI, you can go there and access the images. Create a new image with your own custom images from there as well.
And it's all documented here.
Yep, it's all there.
I'd love to add something there real quick.
Sure.
When you do go ahead and register the image with Compute Engine, we take a copy of the image that's in cloud storage. And so then if you go and change the underlying bits in cloud storage, that doesn't change the image that's get used or launched. So it's really sort of once you register that image with Compute Engine, it's sort of locked in at that point. And you can delete it or create a different image, if you want to update it. And then in general though, we've been encouraging users to use dynamic configuration software. I think it's much easier to keep the image up to date, as bug fixes to our scripts and the stuff that we put in our default images, or if you need to recreate things from scratch, it's a lot easier to do that with dynamic systems. The easiest thing is the startup script that Catherine managed, but if you're building a larger system, you can start taking on systems like Chef or Puppet, or sort of more full-blown providers like RightScale. And so this really, when Catherine mentioned earlier the idea of building an ecosystem, that's really some of the stuff that we're talking about, is being able to plug in to a lot of these management systems that have been built up, as people have started learning how to use the cloud.
Yeah, there's kind of a fine line between the custom image capability and the startup script capability. And just from my own playing with the product, I tend to use the startup capability as my iterative experimentation mechanism, and then when I've got something that's relatively solid, I'll convert to a custom image. Just because the startup thing is more dynamic and lower overhead.
Yep.
Next question.
Sorry, I might just add something.
Mm-hmm.
Yeah.
Because I've just recently been building out a service on Big Cluster for an internal project that will be launching soon.
Compute engine.
Sorry.
It's okay.
My experience with the startup scripts was actually really great, and one of the features that I really enjoyed was the metadata service, so that you can assign a key value metadata to individual instances, and then there's a RESTful interface for accessing those metadata values. And I actually ended up building my service in my server daemon, the capability to query that metadata, and so I was able to do like live configuration of my running services just by using the Compute Engine API. And so I don't know if it's probably the subject for another hangout, but I think that metadata capability is really really awesome, and I'm kind of partial to using startup scripts as opposed to building images, because I find that the ability to iterate on something that is just built live every time is really compelling to me.
Mm-hmm.
One thing I found useful as far as images are concerned, though, is like on some of my instances, actually the ones in the demo that I had that created the fractal image, I wanted to install Java, and installing Java in the startup script did take a little bit of time, so having an image with Java installed already did make it faster. So.
Oh yeah, well I'm a Go programmer, and so deployment in Go is just shipping a binary, so that's a non-issue for me.
Yeah.
There's some really nice things that just work in the startup script, and I think a lot of it is that the networking is set up to just do the right thing, and that you have access to root with sudo, and you have the frictionless gcutil. All of that stuff just being there from the first second the instance comes up is super powerful. So you want to install a package, in that startup script, you do a sudo apt-get of some package, and it just installs. There's no friction. So I would sort of echo what Andrew said. It's a really from my experience, it's a really nice environment for iteratively building these systems.
And also, compared to other virtual machine systems that I've used, the startup times for Compute Engine are really, really great. Like the turnaround time for restarting an instance is usually between a minute and 30 seconds.
Right.
Or less in some cases. And that's just been awesome.
Yep. Yeah. I've been working on a demo that involves 1,000 VM cluster, and that's been pretty important to me, to the speed with which I can start that cluster up and iterate on it. So I would agree.
Somebody ask a question about the startup scripts, though. Is it correct that they run every time the instance starts? So if the instance restarts, the startup script is run again? Is that correct? And is the ephemeral disk totally wiped if the instance restarts?
It depends what you mean by restart. So a reboot will not wipe the ephemeral disk. If the VM has some sort of failure where it fails in a hard way, then the ephemeral disk would be lost.
So our behavior there is I think it's natural for actually how we develop software at Google, but I think it's a little bit of a change from what people might be expecting from outside of Google. Currently, when we see a failure in a virtual machine, so this usually this is a software hardware failure, and we're obviously working to make sure that it's only hardware failures and do what we can to minimize that. But when that virtual machine fails, we'll just restart it with the same parameters. And so if you're looking at something like the demo that you saw earlier, where you're waiting on some sort of signal to do some work, or you're just reading from a queue to do some batch work. That's really a natural thing to do. The VM will fail, it'll come back, and then it'll start picking up queue items and start working on it. We're going to be looking to provide, expanded options in terms of communicating and dealing with those failure situations in the future. That's one of the things that we're looking at, figuring out, what's the best way to handle that, what's the best way to communicate that stuff, what kind of other tools can we provide around that, and things like like booting off of persistent disk that was mentioned earlier as a question is definitely part of that plan. That being said, there's the only time that you'll typically see a reboot of the virtual machine, short of these failures, is if you type reboot from inside the virtual machine. And in that case, you will see the startup script be run again. If you want to, detect whether you're actually seeing the first boot or the second boot with a startup script, you can write like a Sentinel file someplace on the file system to actually sort of say, oh, I've been through this code path before, and detect that. One of the other things I want to point out, and I think this is documented in our documentation, it's a really useful thing for a startup script, is there's a safe format and mount helper script that essentially, like, if we have this idea of extended ephemeral disks or persistent disks, and if you want to mount these things and format them if they haven't already been formatted, that's something that we provide a helper script to do, and then that helps to prevent data loss in case of one of these unexpected reboots for both extended ephemeral disks or the persistent disk. And then also to help make sure that you know which disk you're talking about. When you attach a persistent disk, you can actually provide an alias that shows up in the dev file system, so that instead of knowing, is it is it VDA, VDB, or SDA, SDB, or SDC, or whatever, we actually sort of create an alias there that makes it easy to have stable connections to that. So that's another hint there.
Cool. Thanks. Let's see. Next one is how secure. We already covered that one. How much visibility do Google admins have into my machine? That's probably a Joe question. I'm not gonna.
Very little. I mean, we've tried very hard to make sure that we provide the as many walls and protection as we can. We really take customers' data very, very seriously. This is one of the reasons why we've done that encryption at rest. We do have access to the machines, and and the keys have to be stored someplace, but we have a lot of internal control to make sure that before anybody takes a look at that stuff, that all that stuff gets audited, and that very few people have permission to be able to do anything that could even possibly get to that data. So we're very, very careful about that, and we really take a great pains to make sure that we limit as much access as possible. We actually segment, and control those keys very, very carefully, and we control access very, very carefully.
Here's another one that may be for you, Joe. It says, somebody says, I've seen you have custom-built images based on Ubuntu and CentOS. What has been changed on them, and will people release them for our own servers? And you mentioned earlier that we've locked things down so that by default it kind of errs on the side of security, but maybe you can share.
So the first question, what has been changed? We create these images by doing a dev bootstrap from the ground up and just install. That's at least for Ubuntu, we do a dev bootstrap. For CentOS, I think we take an ISO and install it. And then we go through and we do make a bunch of modifications. Most of those things are additive in terms of adding some extra scripts to actually be able to say to be able to run those startup scripts, or to customize the device file system for those aliases that I mentioned earlier. One of the things that I'd like to see us do is document exactly what we've changed there and really get down to the details. In terms of releasing these things, all the software that's available on these images is available from either in source form on the images themselves, and we don't have any binaries deployed there. And anything that's a binary is available via the ways that you can download source from the distributions. And so with respect to being able to get the source for open source software, that's the way that you can go ahead and do that. In terms of releasing the images themselves as a whole, that's not something that we've thought about. It's something that it's a good piece of data, but most of the customizations that we've made to these images are to make them work well in the compute engine environment. So I'm not quite sure how much sense it would make to have these things run elsewhere.
Cool. Thanks, Joe. A business and investment question. Do you foresee App Engine being cannibalized by Compute Engine? What should we be using? What should we be advising clients? I can take a crack at that unless you wanted to.
Go ahead.
So,
you might have some
yeah,
input too.
we'll ask Amy in a minute. My quick reaction is not at all. In
Yeah.
fact, we think the combination of the two products are awesome. There was a talk at I/O where some of our an engineer and a product manager showed a really cool demo where the two products worked together really well. In my own experience, I've been playing around with the combination of those two a little bit, and App Engine works super nicely as kind of an orchestrator of these virtual machines in the back end. And it's almost like a similar concept to the task queues or the App Engine backends, although those have different capabilities and different features. But the quick answer is I think they work really well together and complement each other. I don't know if Amy or anybody else wanted to add to that.
Yeah, can you guys hear me?
Might need to speak up a little bit. Your audio is low.
And Amy is our App Engine expert.
Right.
Can
Thanks.
you hear me? Yeah, I just concur and say that they're very complementary, and I'd recommend that you check out the Google I/O session. It's very interesting. And one thing that we probably don't have time to get into in this hangout, it's quite a nice pattern how compute engine instances were accessing tasks on a pull queue, an App Engine pull queue to control what they were doing, and that's a very nice way to view the interaction. And at the App Engine end, there was also some load distribution, load balancing of the compute engine instances. It was quite nice. It's sort of different levels of abstraction.
Maybe we can have a session down the road a bit where we could perhaps work with the App Engine, do a joint one of these sessions with the App Engine team and just kind of focus on that subject entirely.
Yeah.
Yeah.
I can probably speak to this a little bit as well, because the service that I'm building at the moment uses both App Engine and Compute Engine. And so just to give you a sort of vague idea of the architecture and the division between each, is that it's essentially a game, a multi-user game. And so the user interface is all served by the App Engine app. And so users join a session, and the sessions are all tracked in the App Engine data store, and scores and settings and all that are tracked by App Engine.
Mm-hmm.
And static content is all served by App Engine. And then when the users actually start interacting with each other in real time, they make WebSocket connections to Compute Engine instances. And so they're able to do like real-time, low-latency communication between players, but with all of the state and all of the sort of typical web appy stuff is handled by App Engine. And so there was a really nice division there, and the respective APIs of each made it really easy to construct this. And I look forward to sharing it in more detail. We're going to open source it and make it widely available. So
Cool.
That should be a great example.
That'd be awesome. And the other thing is, about 10 minutes ago, we just saw an example of an App Engine app that orchestrated VMs, because I think you mentioned this, but Catherine's app is App Engine based and works really nicely that way. Can you show the test sign-up links again? Maybe you can do that while I
Yes. Let me just find
look
that.
down the list for another question here.
Go. Oops.
While you're doing that, I'll just read off one of these. Do you provide an API so that I can programmatically manage my compute instances? Hopefully everyone on this Hangout knows the answer to that. And the answer is yes. APIs and client libraries, as we discussed at length. There is an interaction between this product and all Google products. How? That's a pretty broad question. So, Catherine, thanks for putting the sign up link on there. So you can see the link up on the screen right now if you're interested in that sign up URL. Yes, there are many interactions between this product and other Google products. One that seems pretty clear is the ability to use Google APIs from these virtual machines. So, all the great stuff that you know and love, docs and apps and the data API and maps and everything should be usable from a VM. But the cloud APIs in particular are all usable as well. And as we mentioned earlier, we've taken pains to try to make some of that work more easily by taking care of or minimizing some of the complexity of the process of obtaining access tokens using the OAuth authority delegation mechanism. So there's lots of ways that, and we also talked about App Engine interactions with Compute Engine. So there are lots of ways that that Compute Engine interacts with Google products. And one of the things we're really excited about is for you guys to start mashing things up in interesting and unique ways that maybe we haven't even thought of yet. Do you like Google? Yes.
That is one of the questions on mine.
That's a pretty easy one. Obviously, we're getting pretty far down on the list here. Do you have any plans to allow deployments to more data centers, for example, Europe and Asia? And we definitely want to expand our footprint, but I'm not sure about what specifics we can talk about at this point. I don't know, Joe, if you know what we can say.
Yeah, I don't think we have anything to really talk about right there. I mean, obviously, one of the advantages of Compute Engine that we didn't have a chance to touch on is the fact that it's much more. It takes advantage of Google's global footprint in a lot of ways, and specifically our network footprint. And one of the ways that this manifests is that if you have a bunch of virtual machines in different regions, because right now we have 3 different regions with a zone in each, and they all sit on a virtual network, they can talk to each other across regions, even though those regions might be separated by large distances. And we're going to look to maintain that type of capability as we scale out geographically also. And so as we do look to actually have a larger footprint geographically, we want to make sure that we make it really easy to integrate instead of having to build a bunch of sort of cross-region special code to do that stuff.
Cool. Here's an interesting question. Are the Google APIs accessed from within Compute Engine over Google's internal network or over public internet? Can you describe more which traffic goes where?
So all connections between a Compute Engine instance and any API go over, logically the public internet. They go out through our gateway, and Google sees them come back in with a public IP address. And so if you have an instance that doesn't have a public IP address, it can access the internet, including whether that be the cloud storage APIs or whether that be the Compute Engine APIs or what have you. That being said, practically that data never leaves Google's networks. It just hairpins at a certain point and comes right back in. In addition, most of these APIs, all of these APIs, I believe, are accessible over HTTPS, and so if you're worried about security and eavesdropping of this data, you don't have to worry about that. And we're actively monitoring, making sure that we can provide the best performance available, specifically between Compute Engine and Google Cloud Storage, because we know that the connection there is really, really critical as people build applications.
Thanks. And maybe we have, getting down to the wire here, one more question maybe?
Sure.
Do you provide, no, we already hit that one. Would it be feasible to do socket connections between App Engine and GCE? I think we touched on that one too. Did you say you were using WebSockets, Andrew, in your Go app? So I think
yeah, that's right.
We verified that, and yep, that's fully supported. I think we're kind of out of questions, but we're kind of out of time at the same time.
Yep. So thanks again.
So thanks to
everyone
everybody for participating.
that is watching online, and everybody that joined the Hangout as well. Thanks.
Thanks, folks. We'll do more.
Yep. Stay tuned. We'll.
Yeah, send